This is a tutorial on solving inequalities with variables on both sides. When we solve an inequality with variables on both sides, we would solve it like we would solve any other inequality, except our first step will be to get x on one side of the inequality sign. So if we have 3x is less than x minus 4, my first step will be to subtract x from both sides. If I do that, I'll end up with 2x has to be less than negative 4. Next, I'll divide by 2 because I want to isolate x or get x alone on one side. So if I divide by 2 on both sides, we'll end up with x has to be less than negative 2. Our next equation is 2/3 x has to be greater than or equal to x minus 2. Well, I don't like fractions, so the first thing I'm going to do is multiply both sides by 3. If I do that, I'll end up with 2x has to be greater than or equal to. Now this x minus 2 multiplied by 3 you have to distribute in. So we'll get 3x minus 6. Now I'm going to subtract 3x from both sides. And we'll get a negative 1x has to be greater than or equal to a negative 6. Now I'm still trying to isolate x. So I'm going to divide both sides by negative 1. If I divide negative 1x by negative 1, we'll get a positive x. Now I'm dividing both sides by a negative number, so I have to reverse my inequality sign. So this greater than or equal to sign is going to become a less than or equal to sign. And then a negative 6 divided by negative 1 is just a positive 6. So our answer then is x has to be less than or equal to 6. Our next example is 2x has to be less than or equal to negative 6 times x minus 1. Well, to complete this, we have to simplify first. So to do that, we're going to distribute this negative 6 inside these parentheses. So we'll get 2x is less than or equal to, now a negative 6 times x would be a negative 6x, and a negative 6 times a negative 1 will be plus 6. So we have 2x is less than or equal to negative 6x plus 6. Now I want to get x on one side of this expression, so I'm going to add 6x to both sides. And we're going to end up with 8x has to be less than or equal to 6. Now I'm going to divide both sides by 8. And we're going to get x has to be less than or equal to 6/8. Or if I simplify that fraction, x will have to be less than or equal to 3/4. Now lastly, there's a special type of inequality with variables on both sides. And these are called identities and contradictions. So let's look at these two examples and try to solve them and see what happens. Here we have 3x minus 2 has to be less than or equal to 4 plus 3x. So my first step will be to get x on one side of this expression. So I'm going to subtract 3x from both sides. If I do that, I have a positive 3x and I subtract 3x, I end up with a 0x. So I'm just left with negative 2 on the left-hand side. And negative 2 has to be less than or equal to the right-hand side. So if I have 4 plus 3x and I subtract 3x, the 3x and the negative 3x will cancel on the right-hand side, so I end up with just a 4 on the right-hand side. So my expression has been reduced down to negative 2 has to be less than or equal to 4. Well, that makes sense. Negative 2 is less than or equal to 4. So this is what we call an identity. Since this is an identity, that means it doesn't matter what we plug in for x, this expression will always be true. So the solutions for x then would be all real numbers. Let's look at our second example. We have 7x plus 4 has to be greater than 7 plus 7x. So once again, I'm going to get x alone on one side of the expression. So I'm going to subtract 7x from both sides. If I do that, my 7x and my negative 7x on the left-hand side are going to cancel. So we'll be left with just 4 on the left-hand side. And 4 has to be greater than whatever's on the right-hand side. Here we have 7 plus 7x, and then we subtract 7x. Again, these 7x's are going to cancel, and we'll be left with just a 7. So our expression is simplified down to 4 has to be greater than 7. Well, 4 is not greater than 7. So that means, regardless of what we plug in for x, this expression will never make sense. So because 4 is greater than 7 and that doesn't make sense, that means that there are no solutions for x that will make this expression true. And that completes the tutorial on solving inequalities with variables on both sides.